welcome back. In this video, we're going to look at perimeter, area, circumference, volume, and surface area. So what is perimeter? Perimeter is the length of an object's outer edge or boundary. And the way we find the perimeter is by adding the lengths of each edge. Okay. Circumference is basically the perimeter of a circle. Okay, and the way we find circumference, which is denoted using capital C, is pi times the diameter. Okay, we talked about the diameter in the last video. It's just the length of the segment that passes through the center of a circle from one side to the opposite side. And pi is the irrational number. It's non-terminating, non-repeating. Spelled Pi, it's a Greek letter, and it's approximately equal to 3.14, but it goes on forever and ever. Pi is actually the ratio of a circle's circumference to its diameter. So we can use this formula, pi times d for diameter, but we can also think about the radius, which is 2 times the diameter. So in place of the diameter, I can replace it with 2 times pi. And I can just use 2 times pi times the radius. Sorry, 2 times the radius here. Okay, here's an example where we can use our knowledge of circles and perimeter. A window consists of a 4-foot by 6-foot rectangle capped by a semicircle. How much trim is needed to go around the window? Okay, so first let's look at the rectangular portion. We know we've got 4 feet here, and we've got 6 feet. And I know that across from the 6 feet, the length is also 6 feet. So this part is 6 feet, this part is 6 feet, this part is 4 feet. So we need to take that into account if we're trying to figure out how much trim, because we'll be looking for the perimeter. But then we also need to figure out this part here, which is curved. So right now, I know that my perimeter is going to be 4 feet plus 6 feet plus another 6 feet. But then I need to figure out, maybe it'll be helpful there to put these in parentheses so the t's and the pluses look different. I need to figure out the curved part. Well, this curved part is half of a circle. So I know that really what I'm finding is the circumference of the circle. I know the diameter, which would be 4 feet. So if I can find the circumference of a circle, full circle, and just take half of it, it'll give me the trim here. So normally the formula for circumference of a circle is pi times diameter, but I'm going to do half times pi times the diameter, and my diameter is 4 feet. So now I'm just going to add, I've got 4 plus 6 plus 6, so that's 16 feet, plus half of 4 is 2, so this is really just 2 times pi, and then of course it's feet. Okay, and I know pi is 3.14, so it's really just 16 feet plus 2 times 3.14 feet. So it's 16 feet plus about 6.3 feet Okay, it's really like 6.28, but we can round it to 6.3. And then if I add those together, I get 22.3 feet. So that's how much trim is needed to go around that window. For the check your understandings, you can pause the video and try them on your own. If you have any questions, feel free to reach out. Here's a table that has perimeter and also area. So area is the amount of space enclosed by a figure. We know area is measured in square units. We talked about that in prior videos. Here's a formula to look at the area and perimeter formulas for various figures. So we've got circles, squares. One of the things about a square is that all of the sides are equal. So you could add up all four sides in a square to get its perimeter, or you can just take the length and multiply it by 4. And to find the area of a square is length squared. The area for squares, rectangles, it's length times width or base times height. But again, since the lengths are the same, you can just square the length and you'll get the area of the square. For a rectangle, it's 2 times the length plus 2 times the width, because you have 2 lengths that are the same and 2 widths that are the same. And the area is length times width. For a parallelogram, it's going to be basically the same formula that we use for a rectangle to get the perimeter. They just use B and W instead. And then for the area, it's the base and then times the height of the parallelogram. So that is the difference between the two. And then the triangle, to find the perimeter, it's just A plus B plus C. And to get the area, it's going to be half of the base times the height. And the base and the height will always be perpendicular to each other, so they'll always form a 90-degree angle. And that's how you'll be able to tell what the base is, and then also what the height is. Okay, so let's use those formulas to find the circumference, the perimeter, which, if we're looking for a circle, it's going to be circumference, and the area of a circle with a radius of 3 inches. So let's draw what that's going to look like. Here's my circle, okay, and they tell me that the radius is 3 inches. That means from the center of the circle to the edge on the circle, it's going to be 3 inches. Okay, and let's find first the circumference. So remember, you have 2 choices when it comes to circumference. You could either do pi times diameter or 2 times pi times radius. Since I'm given the radius, I'm going to use the 2 times pi times radius formula. And remember, pi, we're just going to approximate using 3.14, and the radius is 3. And if I multiply all of that out, 2 times 3.14 times 3, I get about 18.85 inches. So that's the perimeter, if you will, of the circle. The area formula for a circle is pi times radius squared. So pi, again, is 3.14. And then radius squared just means times the radius times the radius. And I already know my radius is 3 inches. Okay, so I've got inches times inches, so I know my final answer is going to be inches squared. And if I multiply 3.14 times 3 times 3, you get 28.27. And then it's inches squared or square inches. In letter B, we have a parallelogram. So if I want to find the perimeter, I'm going to use basically the formula that we use for perimeter of a rectangle. In the chart, they change it to like B and W, but you can use length and width if you want. But let's keep it the same. So it's going to be 2 times the base plus 2 times the width. Well, my base is 6, and I know if I go right across from it, this is also 6 meters. So I've got 2 times 6 meters plus my width is 4 meters, and there's 2 of them. So here I have 12 meters plus 8 meters, which is equal to 20 meters. So that's the perimeter. For the area, it's base times height. So again, I already know my base is 6 meters. My height is 3 meters. That's how tall the parallelogram is. And the base and the height will always be perpendicular. They'll always form a 90-degree angle when they intersect. And 6 times 3 is 18, and meters times meters is meters squared. So that is the area of that parallelogram. Here we have a triangle. So to find the perimeter of a triangle, I'm just going to add the sides. I've got 5 centimeters plus 6 centimeters plus 5 centimeters. And if I add them, I get 16 centimeters for my perimeter. To find the area, we're going to do half the base times the height. So my base is 6 and my height is 4. The base and height form a 90-degree angle. And I know that 6 times 4 is 24. And meters times meters is, actually this is centimeters, right? So centimeters. It's going to be 24 centimeters squared. And half of 24 divided by 2 is 12. So I know that my area is 12 square centimeters. Again, here's a check your understanding that you can try on your own. If you have any questions, feel free to reach out. In this next example, you've built a stairway in a new house and you want to cover the space beneath the stairs with plywood. So we're talking about this part right here. The figure to the right shows the region to be covered. So if we're covering a region, we're looking for the area. So how would I find the area of that region? Well, it's a triangle, and I know that the formula for area of a triangle is base times height. And my base here would be 12 feet, and my height is 9 feet. So I'm just going to multiply 12 times 9, which is 108. So it's 108 feet squared. And then half of 108, or 108 divided by 2, is 54 feet squared. Now, another way you can do it is, of course, you can take half of 12, which is 6, and then 6 times 9 is 54. Okay, remember, multiplication is commutative. You can multiply in any order you want, and you'll still get the same answer. Now, going back to this triangle and the other one, we learned how to classify triangles in the last lesson. Can anybody remember what type of triangle this would be classified as? If you said an isosceles triangle, you would be correct. And it also looks like these are 3 acute angles. So we would have an acute isosceles triangle. I know it's isosceles because it's got 2 equal sides. Or in geometry, we say congruent. Congruent means equals. And here we have a right scalene triangle. So none of the sides are the same. And I can tell you that this is not the same either. You could figure out the length of the side using the Pythagorean theorem, which we're going to talk about in a later video. And you would see that this would be 15 feet. It's not going to be obviously the same 3. So it's scalene, and there's a right angle right there. So it's a right scalene triangle. One block, City Park, is bounded by 2 sets of parallel streets. The streets along the block are each 55 yards long, and the perpendicular distance between the streets is 39 yards. How much sod should be purchased to cover the entire park and grass? So if we're covering a space, right, we would be finding the area. And we need to identify the shape. This shape is going to be a parallelogram. So I have area equals, if you'll remember the formula, it's base times height. And my base here is 55 yards. And the height is the perpendicular distance which is 39 yards. So now all you have to do is just multiply 55 times 39, and you get 2,145, and yards times yards is yards squared. So that's the amount of sod that they would need to purchase. The next couple problems are check your understandings, which you can try from practicing the examples we did. Let's talk a little bit about three-dimensional geometry. So what we just dealt with was two-dimensional. When we're dealing with three-dimensional geometry, we're looking at volume and surface area. So what is the difference? Well, volume is the amount of space an object occupies, and it's measured in cubic units. And surface area is the total area covered by the surface of a 3D figure. And since it's area, it's measured in squared units. Okay, now that we know that what volume and surface area are, let's take a look at a couple problems. Here's some formulas that might be helpful to you as you go along. We have a sphere, which is a three-dimensional object. The formula for surface area is 4 times pi times radius squared, and to find the volume, it's 4/3 times pi times radius cubed. For a cube, we have a three-dimensional, like a box. A cube is made of 6 square faces. So we remember that squares have all equal lengths. So one way to find the surface area is just do length squared. So that's the area of one of the faces, and then just multiply it by 6 because there's 6 faces. For the volume, it's going to be length cubed because all the lengths are the same. A rectangular prism is made up of rectangular faces. And to find their surface area, it's this formula here. It's 2 times length times width plus length times height times width times height. But the reason it's like that is because if you think about it, here you have the length times the width, right? So that gives you the area of the top, but the top is the same as the bottom. So there's 2 of those. And then if you want to find the area of this face, it's the length times the height. Remember, there's another one that's just like it across from it. And then the same for this back one and the front. So there's 2 of everything. So essentially you're finding the area of all the faces and then adding them together, which is what we said the definition of surface area was, right? It's a total area covered by the surface of a 3D object. To find the volume, it's going to be the length times the width times the height. And then here we have a right circular cylinder, and the formula for that, the surface area is 2 times pi times radius squared plus 2 times pi times radius times the height. Again, you've got a circle here and there's a circle there. Think of like a can. And there, how do we find the area of a circle? Pi r squared, and there's 2 of them. And then here, it's 2 pi times the radius times the height. Well, 2 pi r is the circumference, really, if you think about the formula. If you were to unravel this can, really what you're finding is the circumference and then multiply by the height. And then for the volume, it's pi times radius times radius times height. So you have the formulas, now you just have to figure out what it is you're finding. So in this example here, it says a water reservoir has a rectangular base that measures 30 meters by 40 meters and vertical walls that are 15 meters high. So if we were to maybe kind of construct a picture, it could look something like this. Okay. And I'm doing my best to make it drawn to scale, but it doesn't always work out like that. So let's see. I want to duplicate that. There we go. Okay, and then I'm going to connect it like this. Okay, so let's label some stuff here. It says a base. The base is the bottom or the top, and it says it's 30 meters by 40 meters. Okay, and then the vertical walls that are 15 meters high. So obviously not drawn to scale, but you get the idea. It says at the beginning of the summer, the reservoir was filled to capacity. At the end of the summer, the water depth was 4 meters. How much water was used? Okay, so this is being filled with water. We've got a three-dimensional object filled with stuff. So we're dealing with volume here. And if we want to figure out, like, at the end of the summer, we know that the water depth was 4 meters. So how much water was used? So let's first find the volume of the reservoir when it was filled to capacity. So at the beginning of the summer, we'll call it V, and we'll put a little subscript B for beginning. We're dealing with a rectangular prism, so the formula is going to be length times width times height when finding the volume. And I know my length is 30 meters, and my width is 40 meters, and my height is 15 meters. And if I multiply them, 30 times 40 times 15, I get 18,000. Meters times meters times meters is meters to the third power, right? Cubic meters for volume. Now, at the end of the summer, we'll call it V and we'll put a little subscript A. It's still 30 times 40, but they told us that the water depth was 4 meters. So I'm going to replace 15 with 4. And if I multiply 30 times 40 times 4, I end up with 4,800 meters cubed. So how much water was used? All I need to do is take the 18,000 cubic meters and subtract the 4,800 cubic meters. And that's going to leave me with the amount of water in the reservoir that was used. So if I subtract that, I get 13,200 meters cubed. Okay, and that's what's left over. Let's take a look at one more example, which deal with two soup cans. And in this can, we need to figure out which can provides more soup. The can with a diameter of 3 inches and a height of 4 inches, or the can with a diameter of 4 inches and a height of 3 inches. So let's talk about the first can. We'll call it can 1. Okay, we're trying to find which can holds more soup. So we're looking for volume. So the volume of a right circular cylinder is pi r squared times the height. So here I have pi times, for can 1, the can on the left, I've got a diameter of 3 inches. I need the radius. So if my diameter is 3, to get the radius, I'm just going to divide that by 2, right? Because the radius is half the diameter. Half of 3, or 3 divided by 2, is 1.5. And I'm going to square that, okay? And I'll put in my units as well. So that's inches. Okay, those two little marks there mean inches. And then squared. Times the height. My height is 4 inches. So remember, pi is just 3.14. So I'm going to multiply 3.14 times 1.5 times 1.5 times 4 inches. And if I do that, I get 28.27 inches to the third power. Okay, so that's for the can on the left. We'll call it can number 1. Can number 2 is going to be on the right. So for this one, it's going to be pi times my diameter is 4 inches. So half of that would give me the radius. Half of 4 is 2. So it's going to be 2 inches times 2 inches times the height is 3 inches. So if I multiply that out, don't forget pi is 3.14. 3.14 times 2 times 2 times 3 gives me about 37.70. And of course, it's inches cubed. So can 2, even though it's smaller in height, it's wider, and it gives me quite a bit more in volume. So the larger radius, can 2 has the larger radius, but the smaller height, and it still has the largest volume. So this one has the largest volume, even though it has the smaller height and larger radius. And that's it. In the next video, we will be looking at problem solving with geometry. We're going to look at the Pythagorean theorem. We're going to look at similarity and other things that are useful in the real world when dealing with geometry. Hope you all enjoy the rest of your day. If you have any questions, please reach out.